relationship between ethos and academic is a very important point. So I would like to thank Professor Elaine and Professor Tom again, and repeat again that we are really glad and happy to listen to you and to your experience. Okay, so then please, thank you.
Well, we're going to see, does this work?
Yeah.
Okay, I'm a rock star. I mean, it's... Okay. So, let's see, is this on now? Yes. Okay. So, Tom and I are going to speak this afternoon about experiences working with industrial partners and working with practitioners, people who do stuff instead of thinking about doing stuff like researchers do. And we're going to tell you some stories about 3 real projects, all done in cooperation with practitioners, and try to tell you some of the things that they all had in common and that we tried to make sure they had in common, and some of the things that worked and some of the things that didn't work. And then hopefully at the very end, I'll tell you the moral to the story. So to start with, I'm going to tell you something about why sometimes these collaborations don't work. And in my experience, when I moved to AT&T Research, or what was then AT&T Bell Labs Research, was that many of my colleagues, my research colleagues, didn't want to have anything to do with the practitioners, and many of the practitioners did not want to have anything to do with researchers. And I couldn't understand this. From the point of view of a researcher, I was moving from a very famous, very good university to industry so that I could have impact, so that my research could be used, so that I could use data, so I could solve real problems. And so why were these researchers not taking advantage of this? And my experience from consulting was that the practitioners were generally very interested in what I had to say. I would listen to what they had, and they would typically be very interested in what I'd have to say. So what was the problem? And then I began to realize what researchers and practitioners frequently have very different perspectives, or at least this is my experience. So you ask them the same question, and sometimes they'll give you the same answer, but what's in their head is very different. So, for example, researchers ask, are practitioners interested in our research? What they're really thinking of, don't they read anything? So notice they, it's we and they instead of a collaboration. So here we're doing this great stuff and we publish these papers, and they should be going out and finding out about it. And then you ask, do they think it's relevant? And what they're really thinking is, don't they understand how great what I've done is? Are practitioners using it? And what they're thinking of is, what's wrong with them? They're not using it, they must not be smart enough. And what can I do differently to get my research used? And what they're thinking is, how can I knock some sense into these people's head? So it's what we would say an adversarial process from the researcher's mind. We're doing great stuff. We put it out there. It's their responsibility to find out about it, and it's their responsibility to use it. And one of the issues is that many researchers have never really done, have never actually engineered any software. Now, from the practitioner's point of view, you ask them essentially the same question and you say, is this research relevant? And what their thought is why don't they solve a real problem? So I can't tell you how many times I heard from practitioners that they look at research that's done and they think it's a solution in search of a problem instead of a solution to a real problem. It's not the problem that they have. They want to know, is it applicable to my project? And what they're really thinking is, you haven't given me any evidence that this is really going to work on a real project like mine, and it's too much of a risk to use it. And why is it a risk? I mean, researchers think, I'm giving you a tool for free. Why don't you just use it? And they don't understand that these practitioners have very tight deadlines, and if they use something that doesn't work, they've squandered spare time that they don't have. Is there adequate tool support? And they're thinking, you call this a tool? Do I have the expertise to use it? And they're thinking, I need to know what? So I mentioned with the fault prediction, they don't need to know, and I showed you with the tool, they don't need to know anything about statistics or that we're using negative binomial. They don't need to know about data mining. It's got to be magic. It's got to all be underneath the hood. But too many of the research solutions that people provide expects people to know a lot of things that they don't. And I'm going to give you an example in a minute of a real project that we encountered. And is it usable for a project of my scale? And typically when you look at research papers, the examples they give you have 50 lines of code, or 20 lines of code, or 100 lines of code, and my system has 1 million lines of code. And so I have no evidence that it's going to work for anything but a toy system. So to start out with, you've got these two very different perspectives. Okay, so the first real project I'm going to talk about had to do with performance testing. So when I first was thinking of leaving the university and moving to what was then AT&T Bell Labs, they had been trying to get me to move for many years because they were familiar with my research, and I consulted for them for a while, and they were very enthusiastic, and I had to decide, should I leave the university and move there or not? So the first thing I did was take a 1-year unpaid leave of absence and try it for a year at AT&T Labs. And so my goal was to get involved with any real project and see how it felt and see whether they'd be interested in my working on their real problems. So I volunteered to give talks to anybody, and I volunteered to help any project that wanted help with software testing. And so I was giving a talk on software testing, and basically this software testing research literature is all about correctness testing or functionality testing. And at the end of the talk, somebody from the development group came up to me and started asking lots of really interesting questions. And finally he said his background was in performance analysis. And so he had been doing performance analysis of hardware systems mostly. And now he had moved to a software organization, and he was asked to do software performance testing. And could I help him with it? And he had some very interesting questions, and I said, well, I don't know anything about performance testing. I know about correctness and reliability testing, and I don't know of any literature on software performance testing. On the other hand, you know about performance, you know about queuing theory, you know about many of these issues, and I know a lot about software correctness testing. Maybe together we could collaborate and do something that neither of us could do alone. And he was obviously very smart and had another really nice characteristic, namely he was Brazilian. And so Alberto and I started working on performance testing together. So for those of you who are not familiar with performance testing, the goal is not to decide whether or not the system works correctly. It's done after the system has gone through unit testing and integration testing and system testing and maybe end-to-end testing or beta test. So you're quite confident that the system works correctly. But even though the system works correctly, it may not be acceptable for the customer, because if every time it runs it gets the right answer, but you need to handle 1,000 transactions per second, and this runs much more slowly and can only handle 10 transactions a second, even though every time it handles a transaction the answer is correct, it's not an acceptable product from your point of view. All right, another possibility is that you need a certain response time. You need to have an answer in less than a second. System gets the right answer, but it takes them 5 minutes. No good. So those are the kinds of things that we're testing for after we know that the solutions are all right. We're testing to make sure that the response time and the throughput are acceptable. And another possibility is worrying about scale. So it may be that you can get the response time and the throughput for your current workload. But what happens if your product is incredibly successful, and before you know it, you have 100 times the customers that you have now, or 1,000 times the customers? Do you have a solution that can scale, that can now handle 3 orders of magnitude or 5 orders of magnitude more than it was originally designed for? And do you have solutions for how to grow the system as your workload increases? In telephony, it's standard that you design the system for what they call low to moderate utilization. So you never use more than 20 to 30% of capacity, so that if there's an emergency and you have a spike in workload, you never lose calls. But for most other systems, you don't have that kind of capacity to burn. And so the question is, do we have a process for quickly getting more servers, or does adding another server, does that solve the problem? One of the things that Alberto and I worked on, we worked with a project that had a constantly increasing workload, and when they reached capacity, as they were reaching capacity, they ordered a new server, and everything went fine. And then they were able to handle basically double the workload. And as it continued to grow, they bought a third server. And now, instead of the workload going up, it dropped like this. And they couldn't understand what was the problem. And the problem was the system wasn't designed to work with multiple servers, and it cached at the server, it cached items at the server level. And when if you go out to main memory to get stuff, it's slow. If it's in the cache, it's much faster. And everything was cached at the wrong server, and therefore they hadn't really planned for scaling. Okay, so these are the kinds of issues that you worry about if you're doing performance testing. And so Alberto and I formed a team. He was a practitioner. He was not in a research organization, and it was his job to do performance testing. I was in a research organization. It was my job to write papers and publish, and I could basically work on any problems I wanted. So we worked together, because this was very interesting and new to me, and we came up with a very interesting performance testing algorithm. We really thought it was novel, it was interesting, and it was very general. It was not for this particular system, because from our point of view, if we could come up with a general solution, then the next project that came along, he'd be all set to test that, because he would have a way of doing it. From our point of view, or from my point of view, we would have another empirical study or another case study of a real system. And so it was very interesting. Okay, so we came up with this generalized solution, and we applied it to the system that he was working on. And it was fabulous. Okay, so the way our system worked is it required that you model the system as a Markov chain. A Markov chain is a finite state machine where instead of having a deterministic next state, you have a probabilistic next state. So 30% of the time it will do this, and 20% of the time it'll do this next, and 5% of the time it'll do this, etc. So you have a series of possible next states with probabilities associated with it. And that's determined by an operational distribution. And the operational distribution gives you information about probabilities of next states, or what's the most likely things to happen next. Okay, so when you model things as a Markov chain, you need to identify so you've got 1 million lines of code, but it's really doing a few fundamental operations. So the modeling requires that you decide what is the essential things that this system is doing. So, for example, if you build a telephone processing, a telephony system, you might have 4 or 5 distinct kinds of calls. You have business calls, and you typically know that from 9 to 5, they get, on Monday through Friday, they get most of their calls. The calls are of relatively short duration usually, very high traffic, and then after 5 o'clock, the traffic starts tailing off, and late at night, it's basically non-existent. Then you have consumer calls, and they tend to be just the opposite. Consumer calls tend to be evenings and tend to be weekends. That's when you get the most volume. And they tend to be bimodal. Either they call and it doesn't answer, so they're very, very short, or they connect and people sit and talk. So the connection time tends to be long. Then you might have emergency calls. In the US, they call them 911 calls. You have some kind of emergency response system. So those tend to happen infrequently. They tend to be of short duration. But when they happen, they must be handled immediately. okay? And then you might have things like best business customers, and I don't know if you've, whether they have, or whether you've heard about net neutrality. So that's for the internet, the question is, should everybody be treated the same, or should you be able to pay more money and get premier service and be able to, Netflix wants their things to stream quickly, and Amazon wants, and so, well, that's always been the way it works in telephony. So if you're a premier business customer, your calls are handled faster, better, never throttled, and you pay more money. So there are, for right now, let's say there are 4 kinds of telephone calls. And you know something about arrival rates depending on what kind of call it is and what time of day and what day of the week. And so you can predict what's going to happen very, very accurately. You can predict what your workload will look like throughout the day and throughout the week. And so, we said to them, okay, you just have to model your system, okay. And we did that for the first project. They didn't even know what we were doing. And they were extremely enthusiastic because we did much more performance testing than they had ever done. We were able to find many more performance bugs before. So typically, performance bugs you find in the field, and they're a disaster, okay? You find out that you can't handle the workload when you have that workload. So they were very, very excited because we were telling them before it went out into the field where the bugs were. They could fix it. And their customers never saw the problem. So once we did this, we needed a way of evaluating how much testing we had done and how comprehensive the testing was. And if you're doing unit testing, you typically measure that in terms of code coverage, things like statement testing and branch testing. I've covered 85% of the statements, or I've covered, or something more sophisticated like database testing, data flow testing, where you look at the flow of data. And that's how you measure how comprehensive the testing is. For system testing, you probably measure what percentage of the input domain you've tested, okay? You've tested, and maybe you've divided them into categories, and you make sure that you've tested some percentage of each of the types of things. For performance testing, what you're worried about is what happens the most, what's most likely to happen. So the probability mass of what's most likely to happen. And if there are some things that may happen infrequently but have very high consequence of failure. So for example, if an emergency call gets throttled, then you want to do a sort of risk-based analysis too. So it's not only the probability of it happening or the frequency of it happening, but also weighted by consequence of failure. So we built a assessment model that looked at that and applied it to the first project. It was a great success. Alberto's management loved what we did, because we found all of their performance problems before they had it, so that their customers didn't have it. And so he said, great, now you're ready for the next project. So he gave us time to work on that. And so for that, we already had a solution. And we knew that there was going to be a never-ending succession of projects. And so we thought we've got to train people in the project to do performance testing. So we went to the second project and we said, let us show you how we modeled the first system, which was in the same organization. And we sat with a couple of testers, and they said they didn't get how we did the modeling. Could we do theirs and they would understand better? So we modeled their system. Then they gave us the information to do the operational distribution. Great success. Again, we found all these problems for them, and we were heroes. So we thought, okay, now we'll build a little tool. And so we built a fully automated tool that took your operational distribution and your system model and input it, and out came this sorted list of the most important test cases. So this was great. So Alberto went to the third, was assigned a third project, and now we had the tool. So we said, okay, just model your system, and then we'll show you how to use the tool. It'll be like magic. And they said, oh, well, we don't quite have the hang of this modeling stuff. And one of the things is that computer science students, we don't teach them how to do modeling. And they just didn't have the hang of it. So then we showed them, okay, look what we do. And once we did it, they said, oh, yeah, that makes a lot of sense. And then they used our tool, and this was great, because out came this whole list of test cases, and they could run it, and it was... So then Project 4 came along, and then Project 5 came along, and again, each time, they couldn't do the modeling. And as long as we were there to do the modeling, it was great. And the minute we were not there, it was not great. And at this point, Alberto had been doing this for something like a year, and had all these wonderful successes, and he got promoted to a new job in a different organization, and there they were. They were left with our great tool, and now all they had to do was say what percentage of the probability mass they wanted to test. And it would magically tell you what the test cases were supposed to be, the actual test cases. But first you had to model it. And after we had done it for 5 systems, everybody loved what we did, but once he was gone. So, was this a successful project? We did. Well, the problem was that we expected some kind of expertise that they just didn't have. So Alberto started as an engineer. Every engineer learns how to model. I had gone, my master's degree is in engineering at an engineering school. I was not nearly as good as him, but I could do modeling. But the average computer science student had no expertise in modeling, and they couldn't get it. Once, out of the 5 projects, we found one practitioner who had been an engineer and who had built finite state models who knew how to do it. But other than that. And so what happened? Well, we did everything right except for one little thing. We solved a real problem. Management came to us and said, solve my problem. Tell me how to do performance testing. It's a real problem. Throughout, Alberto, a practitioner, and me, a researcher, worked together. Both managements were thrilled. because his management was thrilled that we were getting these wonderful solutions. My management was thrilled that I was working with a practitioner because nobody else in my department wanted to do that. And I was really happy. I loved doing it. We automated. We built the tool. The tool itself was very easy to use. We applied it to lots of real projects, and we could show them, look what we got for this project. Look at this list of performance test cases. Would you like that for your project? Yes, yes, yes. The only little thing was it expected that they had what they viewed as exotic expertise. Namely, it required that they do modeling, and they just didn't know how to do that. And so the minute Alberto was moved to another organization, this just died, and it was never used again. So that we learned a very valuable lesson here. So the next thing I'm going to talk about, next example I'm going to talk about is, and I'm going to tell you, is the software fault prediction project that Tom and I spoke about this morning. And I'm going to tell you very little about it because I assume most of you heard that this morning. So in this case, instead of it coming from the development organization, it came from Tom and me, who were both in the research organization. We thought that if we could do the kind of prediction we can, that it would be very valuable. So the first thing we did was we went to testers and developers, that is, real practitioners, and we said to them, if we can do this, we don't know that we can yet, if we can do this, would this be useful? And they said yes. And the first project we spoke to, we said, well, okay. I had worked with the head of testing, doing some other testing for them. I said, okay, here's what we need. In order to try to build these fault prediction algorithms, we're going to need a real system. We're going to need your modification request, access to your modification request system. We promise we will look. We promise we will not touch. We promise we will not change anything. If you want, we can copy your database over to our machine so we won't in any way intrude. So they said, yeah, that would be great. So we got to experiment with this first system, which had been in the field at that time for 3 years, 12 releases. Okay? So that allowed us to determine what were the right characteristics, and we told you about the 5 of them this morning. And then we built a statistical model, the negative binomial regression model. We made predictions for the first system, and we went back to the developers and we said, now here's what we did. We had read the research literature about fault prediction, and they said that the most important thing was to predict fault density. Number of faults normalized by size of the file, by 1,000 lines of code. So we went back and said, this is what we did. They said, no, we want absolute numbers because we do black box testing. The system test organization doesn't know how big a file is, doesn't base testing on how big the file is. What we base testing is on the specification. And so we want to know which files will have the largest numbers of bugs. So we went back and changed what we did and came back and said, okay, now we can do this. And they said, yes. So we listened to what they said, and instead of telling them that no, that's not what they wanted what we did, we said, oh. And we went back and changed what we did. Okay. So once we had done it for the first project, and we did everything manually for the first project. That meant that Tom and I read every single modification request for the project and categorized what was bugs and what were not, and learned how to understand what they put into the repository. And so there was an annual, AT&T had an annual software symposium in which 300 or 400 practitioners came to these talks, and I was invited to do the keynote address. So I gave the keynote address about what we had done for the first project and said, if you're interested, if you've got a project, if you're a test manager and would like us to look at your project, and as I said, that's where we got our next customers for. We're showing them what we did for a real project with 500,000 lines of code. And so then ultimately, once we were on the third project, we built an automated tool. And then we began, quote, marketing it within the company. So letting people know about, we had this. And so we got our first real customer who knew about this and really wanted to make this part of their process. They invited us to come and give a demo. And we had prepared a demo of their most recent release. And we get there, and they say, well, guess what? We have a new release we didn't tell you about. So what we'd like you to do is make predictions for that new release that you don't know anything about right here, right now. So, you feel like your whole life passes before your eyes because we've got this little tool that we wrote, or Tom wrote, and, it works fine, but now we're standing up on the stage and we're going to run it, and what's going to happen? And we haven't gotten to try it. And it was like a miracle. We run it on this system that had more than 1.5 million lines of code. And in under a minute, we had the results. And the whole thing is running, tied into one of these projection systems. And out is coming this list of test me first, test me next, test me that, all in under a minute. And they knew this wasn't fake because we didn't even know about this release. So then the head of development there's there, and the head of testing is there, and he says, wow, this is great. He said, hold on a second, I want somebody else to look at this. So he calls in another manager, and he says to him, it turns out he was the manager for one large subsystem of this. And he says, look at this. They say that the worst file is from your subsystem, the second worst, the fifth, the seventh, the ninth. What do you have to say about that? And so again, my life passes before my eyes. And he says, they're right. He said, actually, we've been having a lot of problems with exactly those. He said, but I see number 12. I didn't know that was a problem. But because we had nailed the ones that he knew about, he believed it. And so he said, and so I'm going to go back and I'm going to do code reviews on exactly, which are too expensive to normally do on everything. I'm going to do a design review and a code review for these small number of files that they say are problematic. And maybe I'll just have to rebuild them. So we were heroes. So the head of development and the head of test said to us, not only do we have this project, but we own two other large projects. So what we'd like for you to do is every month we'd like you to run your tool on the latest release for each of these projects and send them to us. Send us, just email us just what you have up there. And we said, it's easy. You could do it yourself. You don't have to do anything. And we showed them the tool. They said, yeah, well, why don't you do it for us the first, why don't you do it? So we said, look, it takes under a minute. It takes us no time. And that means we'll have more case studies for our publications, and we'll learn new things, and we'll be able to practice and make sure that it works for all different kinds of systems. And so we were really excited because their management was so excited. And what I knew deep down was that once they started getting this information and saw month after month, that they were getting really valuable information, they would get hooked like a drug. They would be addicted to our tool. And then we would hand it to them and move on. And what's more, once they're addicted, their friends are on other projects, and so they're going to get their friends addicted to our tool. And it was going to be great. And this was their top management. Everything was perfect. So I go running back to my manager, and I say, you're not going to believe this. It's so great. They love it. They want to adapt it. And they ask us every month to just send them. She said, no way. It's not your job. It's not your job to transfer technology. I said, excuse me, what do you mean it's not our job? That's exactly our job. Nope. And they shut us down. They said we could not do it, which is because she was stupid. What can I say? She really fundamentally didn't understand. And the other thing that we didn't understand was that AT&T was in the process of shutting down research. And it's now completely gone. AT&T no longer has a research organization. But anyway, so my management said the answer is no. And that ended it. So here's what we learned from this project. We solved a real problem. Again, we worked in collaboration with practitioners throughout the whole thing. We built a fully automated tool. As I showed you this morning, I learned my lesson from the performance testing tool, which was wonderful, except that you needed to do this and that. This one you didn't need anything. This one you needed to know the name of your system and what release you want to make predictions for, okay? And what languages you were interested in. Did you want Java or C++ or all of them, okay? When they said, instead of this, we want this. Instead of fault density, we want numbers of faults. Okay, we changed to what they wanted. We required no exotic expertise. We had management. We had buy-in from development management. Where we blew it was research management, which we never thought was going to be the issue. So that's where we went wrong. And we think it would have been a great success, but we'll never actually know because they shut down all of research, and so now nothing is used. The ironic part is between when they said they were shutting down and when we actually left, we got a patent on the thing. The first day the patent comes in, the head of intellectual property calls us and says, "This is fabulous, how are we going to make a product out of it?" And the answer was, well, you're not, because we're leaving, and that's the end of it. So now Tom is going to tell you about a different kind of project, a third project. Okay?
Okay, so project number 3. The project number 1, the performance testing, this was the problem that came from the performance testing group that needed a solution. The project number 2, the solution was being built, was being thought of by the research department and then brought into the development, and that it was development felt that they needed it. So in both cases, you had both development and research involved. Project number 3 is a little bit different in that respect, because this was a system that was actually being built by what was, I would say, an applied research group. So this was a relatively small project in terms of people. There were perhaps maybe 6 or 8 people who were involved in building a system. And this took place actually at a company I worked before I came to AT&T. So there was not a lot of prior industrial software development expertise in these, let's say, 8 people who were building this system. So I think that was good in a way, because these were typically young people who had good software engineering and good computer science educations. So perhaps they were a little bit more open to new ideas coming. They didn't have any prejudices about the right way to do things to start with. So the problem was, the testing problem was to start by, well, most of these 8 people were developing requirements, designing the system, and writing the code, and one person originally was assigned to generate test cases for the system. So we had a tester, and he should design functional test cases for this system, medium-sized system. And what should the test cases do? Well, pretty much what you would like to see in any kind of system, okay? You want to verify everything. Test cases should include expected results if possible, which actually is not something that a lot of test groups think about particularly. They just think about generating the input side, not the output side, but this is something that we thought of because we were, let's say, well-educated people in computer science. We knew we wanted to be thorough, but there's also, on the other side of being thorough, you don't want to generate millions of test cases because you'll never be able to run them all. And there was some kind of an idea that that since this system was in the process of being developed and the actual system requirements itself were going to be changing, we'd like to be able to have some easy way to update test cases or keep them current with the system. So I don't know if this is ambitious or not. It seemed like a reasonable set of goals for a testing system. So how did we start? The one person who was assigned to write test cases said, okay, I know how the system works, I have an idea of what the functionality is and so forth. So here's a pad of paper, and start writing, or maybe, well, in those days probably just still with a pencil and paper, designing test cases, so writing a test plan. This was quite unsystematic, and the idea of writing comprehensive test plan was in the back of the person's mind, but it's not so easy to do if you don't have some kind of control over the process. At some point it became clear that this one person by himself wasn't going to be able to handle it, so another person moved away from the development side to the testing side. Now we had 2 people on the testing team. The test coverage was better because we had a second person's viewpoint of what was important to test and what the test should look like. But we still were mainly doing ad hoc testing. And there was no precise way to measure the coverage. And here I'm not talking about coverage of the code, like branch testing or branch coverage or path coverage. I'm talking about requirements coverage. So there was no real precise way to do that, to measure that. Okay. We knew we needed a systematic way to generate tests. This system was largely a user interactive system. So a lot of the test cases were actually going to be sequences of operations that a user sitting at a terminal would carry out. So the test cases were not sets of inputs that you would just throw into the system. They were really, a lot of them were sets of instructions for a user to be, what he should be doing and how he should be interacting with the system. So, okay, a lot of these test cases were simply text, but we wanted somehow to be able to parameterize the text. This was the first idea that we realized was important, because lots of these are similar operations, but maybe with slightly different specific values when you perform these operations. We wanted some kind of syntax for the parameters. If you write parameterized tests, then by varying the parameters, you can get a set of test cases. But if you expand those parameters too much, maybe you'll get too many test cases. So there should be some way to control the growth of the tests like that. And as I said already, we wanted to include expected output. And one thing that was important is, suppose I sit down and write some test cases or descriptions of test cases. I'd like for the next person who comes along to understand what I've done. So it should be understandable easily. Okay, so we eventually got to the realization that we wanted something like templates for test cases, which is what we did. So we had these test templates, which had a lot of fixed instructions to a user with basically parameters that could be expanded in some way. We took the idea and we created what we called a test specification language, which was a form for the templates and also then a higher level syntax and semantics which said how to expand those templates to generate more test cases. And we eventually added, well, constraints on test cases, constraints on the generation, so you wouldn't get complete explosion, and output specifications, so a way to describe in this language what the outputs might look like. Okay, and expected results, really the same thing as outputs, I guess. This process gradually grew into what we call the category partition method, which I'll explain a little bit more in detail. We built a tool. Once we had the language, this TSL, test specification language, once we had that, we built a tool that would understand the syntax of how to expand the templates. And we used that tool just on our project, on this one particular project. And it was pretty successful there. We got good sets of test cases, and we were satisfied with the way we tested our own project. But of course, that's just one project. Wasn't a huge project. So at some point when that project finished, we had the remnant, well, not the remnants, we had the results of doing this, and somebody suggested possibly it was a management person or possibly it was the people in the group who actually developed the TSL. I don't remember exactly, but someone said, okay, this is a good, useful tool. Let's try to apply it more generally throughout the company. So we built a more sophisticated version of our tool. We marketed it to across the company, in-house development organizations. And in fact, it was picked up by at least these 4 projects and used successfully. Okay, medical diagnosis, telephone switching software, operating system, and this electric motor diagnosis system. I don't know myself any of the details of any of these systems, but I do know that they're all obviously in totally different areas of application. I can't tell you now what the development methodologies were in them, but since they were in 4 completely separate parts of the company, it's quite reasonable to assume that they are really different methodologies. But this test specification language was applicable and useful across all of them. So basically, we feel very much this was a successful outcome of a research project. Why was it successful as opposed to some of these situations where research results are not successful? Well, first of all, both the original problem and the solution to the problem came out of the same organization. Okay, so the same people who were building this original system are the ones who came up with the idea that we needed to do this. And I think this was a big part of it. The people who actually used this system were the ones who had built it themselves. So this was nice. Now, as I said, the organization, I call it an applied research organization. It was in a research department, but the problem of building this system was assigned to the research department. So what was purely a research department became an applied research department in the sense of we have to build this. So the technology didn't come from the outside. And then the last point, which is really important, is that we were able to see that it was applicable across completely different applications and from groups that had not been involved at all in its creation. The final information about this, I don't even have a point here, but this is important. After this happened, other people in management who I never got to know, I don't know who decided this really is a useful thing. The project was expanded even more, and a group was assigned to actually build a marketable tool. And that, in fact, did happen. And I have learned, but not from my direct experience, but I've just been told that, in fact, this tool now is being used throughout the company as a test generation tool. So this is definitely a successful research project. Okay, I have some lessons, but I think these are pretty obvious things to do. The first one, of course, is not about the research process, it's just about the testing process. And the second one is that when you build something that really addresses a real need, and the people who do the addressing, do the building, are the ones who have that need, then you're going to be successful. Okay, so that's as far as this particular project goes, and the third example. So now I'm just going to spend a little while to tell you actually about the category partition method. So that's not going to be why it's, then you can decide yourself if it's useful or not, or successful or not. So most of this, I think, probably you should all know, right? I mean, computer science people, software engineering people, right? Testing is a sampling activity. You have to choose a subset of all the potential inputs or ways of using the system. You can't test exhaustively in any kind of real problem because it's just completely, it's a total explosion of possibilities. You have to select the samples. The basic operation in generating test cases is some way to partition the entire input space into reasonable chunks, and then you try to test each reasonable chunk with a small number of representative test cases. And that's, in essence, that's the overview of what testing involves. What makes up the input space? We decided when we were doing our first tool, there are really three key things. You have things that are obviously inputs to the system that you're building. You have objects that exist in the environment that the system is going to be operating in, and those two things can be parameterized in some way. And then you have relations between these things, between the inputs and between the objects that exist in the environment. So what we ended up calling the category partition method was a way to define for each of the parameters, the environment objects and relations, the idea of creating categories of each of them, and then partitioning those categories in reasonable ways. And you'll see in a moment a simple example of doing that. So, okay, you create a test specification, and then you use the test specification. Test specification is what the input to the, is what, in the language of what I had before, it's an input to the test specification process. So the TSL, test specification language, is used to write this test specification. So you analyze the functional requirements, identify these three key items, parameters, objects, and relations, and then identify the categories that are important within them, partition them, and then identify constraints that relate the categories. Then use a processor of TSL to generate the test cases, evaluate the output, modify the test spec as needed, so you may go back up again. So this is a fairly straightforward example of kind of an iterative process that you might do. Okay, I think I already said this. A category, it's just a property of the parameter that provides a way to classify instances of the parameter. I'll give you examples in a minute. But here are some sort of general types of things. You might have an input number to a system, okay? So the category is just the range of values that input number can take on. If you have some system that's involving interactions or communications between different units of a system, maybe the state of a port that allows one server, for example, to talk to another server, or a server to talk to a client. How many subscribers in a service, what type of equipment. All these are categories that we would like to identify and then partition. Okay, well, I'm not sure this is in the right place, but okay. So take a simple example, very trivial example, okay? If you have a table which has a list of names and a list of telephone numbers, okay? So each name has a telephone number associated with it. you want to do various kinds of operations on a system like that. One of them might be inserting a new name. You have a new entry with a phone number, you want to put it into the table. Okay. What are the kinds of things that you might do with such a table? You want to look things up that are in it, you want to put a new one in, you want to take one out, maybe you want to find a set of things. So these are just some, it's a very trivial example to give the idea. If you are responsible for testing that system, these are some of the kinds of things that you might want to think of. And you use these kinds of things. As a good tester, you use these kinds of ideas to help you come up with what the appropriate categories might be. Okay. Typical kinds of things that you might want to do. And many, many more always. Okay. For that example, what are the parameters? Well, there are two simple parameters, a name and a number, which you could vary. The object in the environment, it's the table, the table which exists to start with. What are categories? Well, here are some simple ones. You can probably come up with some other more interesting ones or additional ones in any case. So for the name, well, okay, the length of the name might be a category, and the actual set of characters in the name might be a category. For the number, maybe you have the type of the number and the character set. Type of number means, well, you saw in the table there were different kinds of phone numbers. There were very short ones, there were local ones, national ones, international ones. Those are maybe different types of phone numbers. And maybe the character set is different also sometimes. You might be able to use a dash, maybe parentheses in a phone number, and so forth. For the table, at least two of the categories are what's the maximum size this table could ever extend to. Maybe that's unlimited in some implementation. And then the current state of the table is important, right? Is the table pre-allocated with some space and there's a lot of space left? Is it already full of space? That's a type of thing. So those categories, these up here, they're just specific to each of these things. A relation connects two of them. So is a name in the table? That's something important. If you go to put one in, maybe you have to check whether it's already there or not. And is the particular pair already in the table? Okay, you have the categories. Now you have to look for ways of actually partitioning the categories. So useful ways. Again, these are things that testers normally think about, but now what you want to do is, if you're using this category partition concept, you want to think about this in relation to each category. So what are boundary values that are important for the category? What are special values that might become important in a category? What is something where you may suspect that certain points in that category are error prone, so you may have error points. So this sometimes is called error guessing to think about these kinds of things. Actually, these two are the same, aren't they? Suspected danger points, error points. I think it's the same thing. No, not necessarily. Okay. Suspected danger points would be error guessing. Error points here is, I think, referring to places where the program itself might have to be conscious of the user doing something incorrectly. So that would be an error point, an error handling input for the program. So that's not the same things. Okay, so for our simple example, we came up with a category partition specification that looks like this. I'm going to show parts of it at a time. So the categories for the parameters, okay. So the length of the name is the first characteristic. Well, presumably there's only one value in the zero length name, right? There's no name. But maybe you have three. You might think of short names, middle length names, and very long names. Maybe that's important for testing. Maybe it's not important for testing. Maybe if you know the details of your kind of table, maybe these are not important categories. But for this example, where they're considered to be. The name might be only alphabetic characters, but maybe your system would allow some digits also to be part of the name. Maybe not. Maybe some special characters could also be added as a third partition of the characters. And then the number types, okay, you have a short one, a local one, a national one, or an international number. And the characters, maybe a number might only be digits, maybe it also has some of these separator special characters. Okay, that's what the parameter categories might be like. The table categories, the maximum size, and then the state. Okay, maybe there's nothing in it, half full, near full, or maybe it's already completely full. For relations, so I just have two here. The name is either present in the table or not, and a name-number pair is already in the table or not. So this might be a typical category partition specification. So how do you use this now? Well, you want to form test cases basically by combining values from these categories. So one test case is formed by choosing a category and a value from each one of the categories. So we have 1, 2, 3, 4, 5, 6, 7, 8 categories to choose from. So you make a choice of each of these, and that gives you a test case, or it gives you the way to build a test. It actually, what it does is it gives you a template for a test case. And here we have one, okay? So we've picked one value for each category, and this defines the form of a test case, all right? It's not the test case itself, it's let's say, one level up from the actual test case. So to get an actual test case, you have to provide a specific value to meet each of these choices. So you have to pick a medium length name, an area code number, table size. The name, for this one, the name should already be in the table, but the name number combination is not, and so forth. And this gives you a test case. How many test cases do you get? From that simple description that we had, we have more than 3,000 test cases, because you're choosing what's very simple combinatorial forming combinations. That's probably too many to run this test case, or maybe not. Maybe you think it's okay, but let's say it's too much. But if you think about it a little bit, if you back up to here, these two conditions are actually not independent of each other, because if the name-number combination of an input is already in the table, then the name is also there, right? So you cannot have no and yes. It's not possible, right? So what it means is that actually the very last one, we don't multiply 2 times 2, it's just 3 for that. So we get a smaller number, okay? It's still a lot, right? So you would like to be able to somehow control this better. Here's the whole, okay, so this is, if that condition is explicitly put down here, you can have the yes here only if the name present value is also yes. Okay, you can write this in, or you can let the language do it itself, take care of it itself. Now, let's just take a look at one of these things. If you look at the table state, so this is telling you that you can run test cases with the table being empty, half full, almost full, or completely full. Well, if you just use this whole specification, you would generate test templates for each of these values, combined with all the possibilities of all these combinations. Maybe you don't want to do that. You want to think that perhaps, for example, testing the full table, you don't want to have all these things. Maybe it's enough to just have a single test case, or maybe only a few. So let's say we only want to test the table being full if you have a medium length name and a local phone number. And maybe that's enough to test the full combination. Okay? If you don't have this constraint, then you'll get, okay, the full choice combines with 16 possible values of the name length and the number type. And if you put this combination in, if you put this constraint in, rather, then 15 of these 16 combinations won't be generated, just for that, for testing the full table. So you reduce by 540 test cases that you no longer are going to be generating. So this is just, it's just an example of how to do it. And you can have, so I could put this on here now, and that we get a small one. And you can continue doing this. You can put constraints on any of these conditions that you like. And the processor will, in fact, generate templates just for those that you have. Okay, so that's on the input side. We also use the language to describe results, expected results, which can then be linked with the input side of the test cases. So we have the possibility of defining expected results, associating with the generated test cases, and yeah, it can be the case that you can have more than one result on a single test case. And this is just very briefly showing how results might be described. So I've just here you have two different kinds of results. Inserting and is the table overflowing. So let's just look at the overflow part, okay? You get an overflow situation if when you do an insertion, if the table is not full, if the table state on the input side is not full, then you would not get an overflow situation. That would not be a result you would occur. You would get this overflow situation if you try to do an insertion when the table is full. Okay. Okay, you can read this and interpret yourself how that would be, how that would be used. If you put those descriptions, if you put these descriptions of results into the specification, then you could generate a test template which would have this, for example, these inputs, and the test results that are associated with that input template would include multiple insertion and no overflow. No overflow because the table state is not full, and you get a multiple. I didn't go through it, but you can go back and look if you like. You would get multiple insertion because the name that you're trying to insert is, yes, it's already in the table, and so the result would be that the insertion would create multiple entries with that name. And this may be useful for your test case, for checking the result of your test case. Okay, what can you do with the results? Well, you can specify the output checking actions to occur for a given result. You could group all tests that produce a given result. That might be helpful for people who are actually, for the developers or for the testers to know this. You can actually identify test cases that produce no result at all if you define your results properly. Okay, so this is a summary of what we think are the good points of category partition method. It's definitely going to be systematic. It improves very much ad hoc test designs, and you can build into it the error guessing idea. You get a very concise representation. I mean, on a single slide, I had a specification that had the potential of generating 3,000 test cases. It documents the test cases, and maybe most important is it gives you a concise way to control the generation of test cases. It's easy to update. It should be easy to understand by a new user who comes in, and of course you have the control of the test suite size by these constraints that you can apply. Okay, now I don't know, Elaine, do you want to finish with a wrap-up, or should I just go through these? Okay, all right. Okay, so we gave you 3 examples of projects that were associated with research, 3 different outcomes. The performance testing one, a successful solution, but it wasn't widely usable because there was simply not the will or maybe the ability for the potential users to understand everything that they had to about how to use it. For the fault prediction system, it's a good solution, probably was usable, but the research management really didn't have the right kind of buy-in or the right kind of understanding of how this could be applied to systems. And the test case generation started with a successful prototype, which was very simple in the beginning, and it just continued on and successively improved. So, the bottom line, you certainly want to be developing you want to be solving real problems. This is important for research. Of course, there are always going to be people who are going to be sitting in a lab and dreaming up theoretical solutions, maybe to theoretical problems. Sometimes that's going to be good, but by far more often it's going to be good when you have real problems in front of you and you set out to solve real problems. Keep the practitioners aware of what you're doing. Don't just sit alone for 6 months or a year and come up with great ideas without knowing what the real impact and the real potential use is going to be by the users. Tools are important, especially for software systems. I mean, that's something I think we all know, right? Tools are important. Applied to different projects, real projects, and then you clearly need the buy-in on both sides. If you have research management that's controlling what your job is as a researcher, they have to have a proper awareness of what your ultimate goal as a researcher is. Okay, so I think that's probably the end. Okay, so if you have questions, fine. If not, go and
have fun.
Have fun, right? Yeah.
Just a curiosity. Did you ever hear about a software called X?
ACTS, yes. Mm-hmm. It's definitely some similarities to it, yes. And I've talked to the people who have done ACTS, and actually at one time, it's a couple of years ago already, I think, we were going to get together and see how we could maybe merge the ideas in some useful way. It hasn't happened yet. I don't know if it's going to be. I was still at AT&T when we were doing that talking, but it came just at sort of the inflection point when AT&T research sort of went downhill and turned off. So maybe at some point we get back and do that. Yeah.
What is the
Okay.
status of the tool now? Can we use it?
The tool, by the tool you mean which? The test generation? This is something, it is apparently something that you may be able to get from Siemens. Didn't say anything. I didn't say what it was, but this original small project was with Siemens Research. It's quite a long time ago now. I left Siemens at one point. Well, the tool was actually well developed. It had been applied to the medical diagnosis, the electric motor diagnosis system, and so forth while I was still there, although I was not directly involved in any of those projects. And within a couple of years after I left Siemens to go to AT&T, then they did this marketable tool implementation. And my understanding is, I don't know, my understanding is it's used throughout Siemens for internal software projects. I don't really know. I have not ever seen any outside marketing of it. I don't know if they market it to the outside.
What I've heard is they decided it was a competitive advantage
To keep it inside and not go.
internal
Yeah.
tool, and not that they really didn't want to be in the software marketing business, tool marketing business, and that it was better for them to keep it for themselves.
Yeah, okay, so that's true. Siemens doesn't build software systems. They build medical diagnosis systems and
Well, they build software
automotive.
systems.
They build complete software systems to solve specific problems, but they're not really a software house in that sense. Yeah.
Keeping that to give more advantage for them.
Yes,
Yes.
exactly.
Apparently that was the decision. Yeah.
It's what our usually reliable sources.
Bell Labs had a tool like that they use internally, but they did sell it.
It was very common to have internal tools and then some of them, like Unix, they licensed to Berkeley, and Berkeley sold it. And so that was another model that they had, either keep it internal or basically give it to somebody to productize it and sell it. And often they would buy it back from them once it was.
When you make the
Can you speak a little bit?
Take this.
I'll take the phone.
Please turn it on. Oh, wow.
Okay, couple of questions. When you automate the tool and you need to take data from the databases, how willing are they to support you to automatize this process in AT?
So you're talking now about the prediction, the fault prediction tool, right?
In the fault prediction tool, how did they help you to automatize the data
data
generation?
collection?
Yeah, correction.
The way they didn't do this at all. What we got the documentation of the database, and we had to do a lot of studying to see how they actually stored the data. We had to first decide, because these databases, they put an enormous amount of stuff into each trouble report, each problem report that they file, each MR. So we were interested in a small part of that. So we had to actually go in and we had to find where the information is in there. And actually we had some help from guys in the project who understood those databases because they'd worked with them for years.
And in many cases, and this is something else that helps make collaborations between practitioners and researchers helpful. So there was a tool, one of the early systems that we looked at that was very helpful to us. They would answer all our questions and spend time showing us how, because they felt ultimately it'd be good for them. And then one day we got a call from them and said, we've been spending our time helping you. We need help with metrics. And so we did their metrics for them in payback for them helping us. So we did get help from them, but basically we did all the data mining. We had to understand it. We didn't really ask them. And in fact, when they decided, I don't know if you were here this morning, initially we were going to use R, an open source statistics system, and AT&T said you can't use open source software in your project. So now we needed a system that would be free and that could do the actual statistical. And we felt that neither of us were good enough to do a production grade tool. And so I called a manager that I knew that I'd worked with over the years, and I said, this is what we need. Can you give us a professional toolsmith to do it for us? And he said, well, everybody's busy, we have very tight deadlines, and he put me in contact with somebody in his organization, and when I told him about it, and I said, wouldn't this be great? And he said, yeah, I think I can do it over the weekend on his spare. So he did it for us in his spare time. But, so we did get lots of valuable answers to our questions. We did get some help with the understanding how they use the database, because although we had the documentation, it was hard for us to understand. But by and large, we did everything ourselves, just the three of us.
That's very nice that these people help you in their spare time, because that I don't usually see.
Well, it just shows that there are, A, they felt it was valuable enough, which we thought was wonderful, and B, this was a guy who didn't have a life. He says, oh yeah, I can do it over the weekend. And, most people think, oh, I could go to the beach over the weekend. He says, oh, I could write a software system over the weekend. So it's nice to have computer science.
And the second question would be, once you have the tool, how do you disseminate it and convince them to use it?
Okay, so as I said, you have to treat it like a drug. So you get the first, you sit with the first projects and you get them to see how valuable it is for them. And then they have friends who, when you give a talk, and we volunteered to give talks anywhere. So we gave talks, I gave a lot of talks to organizations, and then I say, if you want to know some people who have some experience with it, talk to this project, and they've got friends on these projects, and they know these projects are a lot like theirs, or maybe they used to work on that project, or maybe somebody who used to work on this project comes and moves to this project and says, we have access to this tool. And the best part was, which I didn't mention, the group that owned the modification request system thought this was great. And in particular, they thought that this would help more projects use their tool if they could offer this as a free service of their tool. So they embedded this into their dashboard. So anybody who used their modification request system would be able, as one of the things on the dashboard, be able to say, make fall predictions for me. And so that's really it. You've got to get, and you've got to be willing to, when they say, okay, what's in it for me? If I help you, you have to be willing to say, okay, I'll do your metrics for you. Or when Alberto and I did the performance testing, I would go in and do test planning for them for free. It wasn't my job. I was a researcher. So I thought, well, if I do test plans for them, number one, then they'll be interested in what I'm doing. And number two, I'll learn something that somewhere down the line will make whatever research I do better. Because I will know what the reality of test planning is. And what's the hard part that maybe I want to automate. So that's really... and we thought that, that this was wonderful, having access to real projects and working with them and doing stuff with them. And I think that's one of the big, I'll give you one other quick example. One of my former PhD students was now a very well-known professor at a university. And we did something about testing database systems. We did some research about testing database systems, and I hired, I provided internships for a couple of her PhD students, and I paid their salaries. It was great, and we came up with a database system. Now my goal was to get some real people to use it. Her goal was to read papers. And I wanted to write papers too, and we did write papers. But finally, I managed to get a project that was willing to try it for real. And I'm so excited, and I call her up and I say, guess what? I found somebody who will try our system. We'll try our database testing system. And she says, well, what are they going to pay you? They're not going to pay you. We should be paying them. And anyway, we paid for the graduate student. I paid for the graduate student. So she said, no, if they're not paying me, I'm not doing it. And to me, it was, well, you've really missed the boat. I mean, and so nothing ever happened with that research. Because, which is a shame, because what could have happened is we could have had some real experience which could have eventually led to some real money for her and for me. But, I think you have to be willing to put in something to market things. And, do internships. If you have the opportunity to do an internship, I can tell you my daughter is a PhD student in a different field. And this summer, she's doing an internship at a company because, and I just spoke to her, she's all excited. She's learning things that she didn't learn at the university. And at the university, they are maybe much smarter, but she's learning about reality, which will make her research much better.
You said a couple of things about all these collaborative projects and you working as a researcher and as a professor, and also Tom as a a guy from industry. I was wondering, how do you think how hard is for someone from the academy to start a project like this, and from someone from industry to start a work like this? Because I mean, people from university, they have kind of free time to think things, new things, and people from industry often they are just like customer interests oriented. How hard do you think that from someone to academy to industry to start something like this?
So when I started working with Alberto on the performance testing, I was still at the university trying to decide whether or not I would move to industry. And so I had all the free time in the world to do this. His boss only wanted him to, do performance testing for this. And he was very smart, but wasn't his job title as far as his boss was concerned. So what we said to the boss was, if I work with him on this, and we can get it done, we can solve the problem in the time that you expect him to do it by himself, can he participate in my research project? And the guy said, yes, and I was coming 1 day a week to start with. I was consulting for them 1 day a week. And so I asked my management, would they pay 20% of Alberto's time? And they said, yeah, they would. So I went back to this manager and I said, okay, can he spend 20% of his time working in research with me? And we'll pay 20% of his, and research will pay 20% of his salary. And the manager was really smart, and he said, I'll do it for free. I'll pay his whole salary because I'm getting you for nothing. And so he understood that his job was getting done, and if he made his employee happier, all the better. But it was being done in the allocated time. And so you can get managers who have a sense. I've been working with a Swedish university, and I have a PhD student there who started out working 1 day a week for local industry, a local Swedish company, and now they're paying for his 2 days a week for his stipend, of his pay. And I went and spoke to them, and they're very interested in, so they have management people there who understand that supporting their research and they can get their own job done better. So, if there's some kind of mechanism, and I think that Professor Maldonado is trying to facilitate that kind of thing, and I'm sure other people as well, of these collaborations, these institutes that collaborate between academics and industry, and maybe the industry partner pays some money to help support the researers to solve their problems, to solve problems that will be usable by them. And I think that's the real future certainly of software engineering, because if we as a community, we researchers, don't learn to understand that we have to solve real problems. It's engineering, software engineering. If we don't solve real problems, then it's really, it's just much less interesting, at least from my point of view. Maybe it sounds grandiose, but I feel that what I've done has made a difference to some people. There are real people whose products are better because of what I did. That's what it's about. Plus, I published a lot of papers. Plus, I traveled to Brazil. I traveled to, I'm a kid from New York. This is very exciting, I never thought that I didn't know people traveled when I was growing up, So this is, it's very interesting.
Any other point? No? Okay. Before I finish, I'd like again to thank you. And we are going to have a break here now. And after the break, Ricardo, you want to talk to them, right? Today? Where is he? Okay. So we can talk a little bit. Okay. So, and we hope if you have any question or doubt or need in the future, write to me. I can address them to see if they can help or collaborate. Okay. Okay, thank you.
Thank you all.
I'm very excited that there are women in my audience. I'm so used to speaking to a room of nothing but men. It's so wonderful to see women here.
Yes, sir. Take the time, just 5 minutes. Tell about your activity in ACM.
Okay.
Sure,
So,
it's very
the
You
ACM,
want this thing? Or just take the
yes.
so for anybody who doesn't know, the ACM.
Just a touch.
This one?
Just tight. You push the big one twice. Twice.
So for anybody who's for anybody who's not familiar, the ACM is computer science, the International Computer Science Professional Society, and for 8 years I chaired the Women's Council, which tries to encourage women to be interested in computer science because we have so few of them. And the world is missing 50% of the population. I also work with a group in the US which is trying to increase diversity in terms of minorities. In the US, the problem is the minorities are Black, Latino, and Native American. Try to increase the participation there. But from the international organization, we're trying to increase the number of women. And so and we offer lots and lots of services, and it's, you can just Google ACM Women's Council, and we have a website. And I sent Professor Maldonado a pointer. One of the things we offer is small scholarships to allow women to attend a research conference. And it's competitive, but the goal is to encourage women to find out that there's research out there. Maybe it's your first conference. We tend to target not the most advanced, not the most, the ones who are already committed, who already are about to go out and get a job and finish their PhD. We send undergraduates, we send master students, we send beginning PhD students to conferences, and you can apply from it. It's competitive, but we send students all over the world, from anywhere in the world. You don't have to be an ACM member. You must be a woman. Sorry, guys. You must be a woman. And so that's something you might look at. We run what we call local. So we run these little local conferences, and we've run them. We've never run one in Brazil, although I spoke with Claudia some years ago about doing it. But we run little mini conferences. I don't know if any of you have heard about the Grace Hopper Conference. And these are little mini conferences, again, for women. We pay expenses. And it's so that in many places throughout the world, there are very, very few women. So they may be in the department and they feel completely isolated and frequently, and so this is a chance to create a community. And sometimes the community is not at your same university, but someplace, so there's a federal university in the same city. And so maybe if you had 2 women here and 3 women there, you could still get together and have a community. And in some places, we typically make it so that it's 2 hours diameter, circle. The British women just did did one, and now we just had our first all-European one. Which was run by the European subsidiary now. We spun off ACM Europe women. And we haven't had enough buy-in from South America yet, but we could. Yes, and so, or just Brazil. We usually find it easiest, especially if there's if it's international, if it's a single country.
We have an annual meeting for the special meeting for the
right,
and also we are doing that in South America in Clay.
Okay.
Okay, so
I knew about the Brazilian Computer Society, but I didn't know about South America. That's wonderful.
to think about it, maybe organize something here in some campus.
Yes, exactly.
Yeah.
Exactly. And we usually get, a one or more senior woman who's not local to come and give a technical keynote address to this meeting, which usually we can get ACM to pay for. And so, and what it requires is buy-in and people to do volunteer work to organize it, because you have to organize it locally. I can't come in and tell you what's right for your local facility. So you need women students to volunteer, you need women faculty to volunteer. Men can come. We do, one of the things for the scholarships, it's only for women. For these little conferences, we always have a few men. In many cases, the only faculty are men, and so the men faculty volunteer to get involved in this. But we want to make sure that women are empowered and tend to be the majority. So for once, you can look around and see other people who are successful that look like you. And that's very, very important for people, is to look around and say, and I'm sure when you go to a conference and you see a Brazilian, you feel some kind of pride. And look, somebody who looks like me is a success, and I can do it too. And that's part of the motivation to get the reason that we want to increase diversity in all kinds of both gender and race, and is to empower people to know that they can do it too, that if they work, they can be successful. And that it's not, so many of us look and we see, particularly in the US, we see nothing but white men who are in charge of everything. And you get the message, I don't belong because the people who are in charge don't look like me, and I'm not welcome. And we want the message to be, computer science will be better, software engineering will be better if we use all of the talented people. And that's really the motivation.